Continue on with section 1.7. We're in part B of this section because we're going to talk about piecewise functions. You learn about these in Algebra 2, but basically a piecewise function is like a puzzle. It's pieces of functions that come together to make one big function. So on our notes, you'll see there's a paragraph at the top of your worksheet, and I'm just going to summarize basically what it says. It says piecewise functions, so they are pieces of different functions on one graph. Each function is defined for different intervals of the x values. So again, we're basing our functions on x. We can use the x values to look up which function to plug the number into, and the result will be the y value. So we're plugging in x, and we're going to get out a y, just like we did before. And that's basically what that paragraph is summarizing. Let's look at our first examples. I'm going to do 1 through 6 with you. It says use the given value of x, evaluate the function. And our function is f of x equals, and we have these squiggly bars, 4x minus 3, where x is less than 0, and 1/3 x plus 2, where x is greater than or equal to 0. So we've got one big function, f of x, broken up into two different pieces. What we're going to do to evaluate is decide where the x value goes, because we've got two intervals. X is less than 0, and x is greater than or equal to 0. So -3, is that less than 0 or greater than or equal to 0? Right, -3 is less than 0. Because it is, I'm going to plug it into my first interval. 4, in place of my x, I'm going to put -3 minus 3. Okay, so first thing, decide which interval it goes into based on your x value, and then whichever one it goes into, that's what you're going to put in place of the x there. And then we just simplify. 4 times -3 is -12, minus 3 is -15. So my input was -3, I plugged it into that interval to make -15 when I simplified it. Let's go ahead and do number 2. 1 is my x value. Is 1 less than 0 or greater than or equal to 0? Right, 1 is greater than or equal to 0, so I'm going to plug it into that function. 1/3 times 1 plus 2. And simplified. 1/3 times 1 is 1/3 plus 2. You could write that 2 and 1/3, or you could leave it as an improper fraction, 7/3. Please don't put a decimal though, just leave it as a fraction. Let's try number 3. F of 4, it's my x value. Which interval does it fit into? The first one or the second one? Is x less than 0, or is x greater than or equal to 0? Right, 4 is greater than or equal to 0, so I'm going to take 4 and plug it into my function. 1/3 times 4 plus 2. This is going to be 4/3 plus 2. You could leave it 3 and 1/3 if you type it in the calculator, or just 10/3 would work as well. Either one's correct. The improper fraction or the mixed number. Okay, let's try the last ones. X is 0. So is 0 less than 0, or is 0 greater than or equal to 0? Right, 0 is greater than or equal to 0, because 0 equals 0. So I'm going to take my x, plug it into that function in place of its x. 1/3 times 0 is 0, plus 2 is just 2. Okay, number 5, f of -6. My x is -6. Is -6 less than 0, or is -6 greater than or equal to 0? Right, -6 is less than 0, so I'm going to take -6 and plug it into that top function, -3. 4 times -6 is -24, minus 3 is -27. That's simplified. And last one, f of 7. 7 is my x. Which interval does it fit into? Is x less than 0, or is x greater than or equal to 0? 7 is greater than or equal to 0, so I'm going to plug it into the bottom function in place of its x value. We get 7/3 plus 2, because 7 times 1/3 is 7/3, plus 2, you could leave it 4 1/3 if you type it in the calculator, or you could just leave it 13/3 as the improper fraction. Okay, either one works on those. And that's how you evaluate a piecewise function. Take what the x value is, decide which x interval it fits into, and then plug it into the function that the interval fits in. I'm going to let you guys try 7 through 12 on your own. If you need help, you can stop and take a look at my key. I posted it on Canvas. I'm going to go ahead and move on to number 13. Okay, on number 13, we're given a function, f of x equals, and it's a piecewise function because I've got two different pieces, 2x plus 3, where x is less than or equal to 0, and negative 1/2 x minus 1, where x is greater than 0. And I've got a table there with some x values. I'm going to write down the equation I'm going to use in the second line, the actual y value that I get out in the third line, and then the ordered pair in the last line. So let's go plug them in. My x value is negative 2. Is negative 2 less than or equal to 0 or greater than 0? Right, negative 2 is less than or equal to 0. So I'm going to plug it into the top function. 2 times negative 2 plus 3. That's my equation. My f of x, 2 times negative 2 is negative 4, plus 3 is negative 1. And then putting the 2 together, my x value was negative 2, the y was negative 1. Okay, so all that is just taking what we know and plugging it in for what the x value is, and then getting the y and writing the ordered pair. Let's try negative 1. Negative 1, which interval does it fit into? Right, the top one again. Negative 1 is less than or equal to 0. So I'm going to put negative 1 into my x value plus 3 and simplify. 2 times negative 1 is negative 2, plus 3 is positive 1. And then I put them together, negative 1, 1, as my ordered pair. Let's go plug in 0. Which interval is 0 going to fit into? Right, it's going to fit into the top one because 0 is less than or equal to 0. So 2 times 0 plus 3. 2 times 0 is 0, plus 3 is 3. And there's my ordered pair. X, 0, y was 3. Okay, if you notice on my piecewise function, though, the pieces break apart at 0, right? Both of those intervals have a 0 in common. So I'm actually going to plug in 0 into both intervals, okay? Because that's where the piecewise function breaks apart, I'm going to plug 0 into both of my intervals. So if I plug it into the next one, negative 1/2 times 0 minus 1. Negative 1/2 times 0 is 0. Minus 1 is negative 1. So then we have another ordered pair at 0, negative 1. Okay, so to distinguish the difference between the 2 points, since 0, 3, 0 was less than or equal to 0, I'm going to use a closed dot at that ordered pair to show that it was equal to 0. 0, negative 1, that one was plugged into the interval that was not equal to 0. It's where it broke apart. So I'm going to use an open dot on that ordered pair. Okay. So you have to plug it into both functions because it is where the pieces break apart at. Where you plugged it in and it was equal, you use a closed dot. Where you plugged it in it was not equal, we used an open dot. Okay, so just be mindful of that with piecewise functions. Let's keep going though. So if I plug in 1, which interval does it fit into? The top or the bottom? Right, the bottom. 1 is greater than 0. So I'm going to plug it in. Negative 1/2 times 1 minus 1. Negative 1/2 times 1 is negative 1/2. Minus 1 is negative 3/2. So our ordered pair is 1, negative 3/2. And then 2. 2, is it plugged into the top or the bottom interval? the top. 2 is greater than 0. Negative 1/2 times 2 minus 1. Negative 1/2 times 2 is negative 1. Minus 1 is negative 2. And that's our ordered pair. 2, comma, negative 2. And that's all of our ordered pairs for our table. Now that I've got my table, let's go graph our ordered pairs. Negative 2, negative 1. Negative 1, positive 1. 0, 3, remember that was equal because we plugged it into where it was actually equal to 0. So we're going to use a closed dot there. And I'm going to connect my graph together. And as you can see, 2x plus 3, that is a line. So I'm just going to extend my line this way. Okay, the reason I'm extending it to the left is because x is less than 0. And that's where these x values are less than 0. That's why I'm extending it off to the left, because those are less than 0. Let's go do the other graph. 0, negative 1, right here, as an open dot, because that's where it was not equal to 0. I plugged it in, but it wasn't into the one that was equal to 0. 1, negative 3/2 is like right here. And 2, negative 2 is right here. That one's also a linear equation, so I'm going to extend my line going this way, going down. On that function, why did I extend it to the right? Good, because that's my interval. X is greater than 0, and that's where the x values are greater than 0. If I go off to the right side of my graph. And that is our piecewise function. Let's try another example. Number 15. H of x equals x plus 4, where x is less than or equal to 0. And x squared is where x is greater than 0. So again, I've got some x values. I'm going to plug it into the equation, find what my point has to be, and then plot it on my graph. If x is negative 2, which interval does that fit into? Right, the top one. Negative 2 is less than or equal to 0. So I'm going to plug in negative 2 into my function. Negative 2 plus 4 is 2, and there's my ordered pair. Negative 2, comma 2. Let's keep going. Negative 1, does it fit into the top or the bottom function? Right, the top one. Negative 1 is less than or equal to 0. Negative 1 plus 4, plugging it on in, is 3. So negative 1, 3 is my ordered pair. And then 0. What happens at our graph at 0? Right, that's where the graph breaks into the two pieces. So I've got to plug 0 into both equations, one with a closed dot and one with an open. 0 is less than or equal to 0. So I'm going to plug in 0 plus 4. And I get 4. So here's my ordered pair, 0, comma 4. Because that one was equal to 0, that's a closed dot. Let's go do the other one. 0 squared is 0. So then I have 0, comma 0 as an open dot, because that one was not equal to 0. 0 greater than 0. That was not equal to, that's why that has an open dot. Let's keep going. 1, which interval does it plug into, the top or the bottom? Right, 1 is greater than 0, so I'm going to plug it into the bottom one. 1 squared equals 1, so there's my ordered pair of 1, comma 1. And same thing with 2. Which interval does 2 fit into? The bottom one. So 2 is greater than 0, and 2 squared equals 4. There's my ordered pair, 2, comma 4. Okay, now we've got our table all filled out. Let's go graph it. Negative 2, positive 2 was a point. Negative 1, positive 3 was another point. And 0, 4 was another point with a closed dot. And those came from the top equation where x is less than 0. So I'm going to go to the left side of my graph where the values are less than 0. Let's go do the other one. 0, 0 was an open dot because it wasn't equal to 0 in that function. 1, 1 is the second ordered pair. And 2, 4. All of those values came from this equation where x was greater than 0. So that's why x squared is in use. So I'm going to connect my dots together and go off to the right.